So far, we have been solving different kinds of equations. If you look at the top, we have a two-step equation and a multi-step equation. But now, what do we do when we have the variable on both sides? Well, here are the steps to follow. You first want to look to see if you can apply the distributive property. And after you do that, look to see if you can combine like terms. But the key thing is, the like terms have to be on the same side of the equal sign. You can't combine across the equal sign. And then you want to look to move all of your variables so they're all on one side of the equal sign. And then once you're down to that, you should be looking at a two-step equation where you can just use inverse operations to finish. Here's our first example in which we have variables on both sides of this equal sign. So go through the steps. First, is there anything to distribute? No, because there are no parentheses. Are there any like terms to combine? And in this case, there are not, because they have to be on the same side of the equal sign. Students often confuse this and say, well, 6x and x are like terms. However, they're on separate sides of that equal sign, so you can't combine them. So now we're to the step where we can move our variables to one side. And it does not matter which side you move them. But I'm going to move this x to the other side, and that's a positive x, so I'm going to subtract x on both sides. On the right side, my x's cancel, and I'm left with positive 13 equals, on the left side, I can combine. I have 6x minus x, which is 5x, and then I have this minus 2 that will come down. And now that I've moved my variable to one side, I'm down to a two-step equation. So I can add 2 to both sides. So my 2's cancel, and I'm left with 5x equals 15. And now I can just divide both sides by 5. So x equals 3. And after you get your solution, don't forget to check your answer. Just remember, when you check it, you now have to plug in your answer into more than one location. You have to plug it in on both sides. So here I've plugged in 3 on both sides, and let's simplify. 6 times 3 is 18, and 18 minus 2 is 16 on the left side. And on the right side, 3 plus 13 is also 16. So we created a true statement because we have the same thing on both sides. So that means our answer checks. Okay, example number 2, variables on separate sides. First step, look to see if you can distribute anything. And in this case, we can because we have a set of parentheses. So let's do 7 times 3 is 21. And then 7 times a negative k, so that'd be minus 7k. And that equals negative 3k plus 4. And after you distribute, look to see if you can combine like terms. We have 7k and this 3k, however, they're on separate sides, so we cannot combine them. So in this case, there are no like terms to combine. So now we can just add or subtract our variables to get them onto one side. When you do this, you can move them to whichever side that you prefer. So I have a lot of students that always take the right one, and then do the inverse to always move it to the left. So some students every single time will do that. Or some students will look to see, well, I'm going to move it to whichever side makes my variable positive, because that is easier. So in this case, they would move this negative 7k, because if you add it to the other side, you would end up with a positive number over here. So it's your choice. I generally just always move from the right to the left, but you can choose which way you like. So I'm going to add 3k to both sides. So my negative 3k, positive 3k, they cancel out on the right, and I'm left with a 4 equals, on the left, I have 21 minus negative 7 plus 3 that would be minus 4k. And now to a two-step equation, I need to move the 21 to the other side, and since 21 is positive, I'm going to subtract it on both sides. So they cancel on the left, and I'm left with a negative 4k. And now I just have to do 4 minus 21, which is negative 17. And now divide both sides by negative 4. And you should get that k equals a positive 4.25. So there's my answer, but don't forget to check by plugging in your answer into all of the variables in the original equation. So here I have plugged in 4.25 on both sides, and I can simplify. On the left side, you should get negative 8.75. And then on the right side, you should also get negative 8.75, which shows that our answer is correct because we get the same thing on both sides. Here is our last regular example before you see two special cases and a story problem. So let's go through all of the steps. First, look to see if you can distribute. And in this case, we can distribute on both sides because we have parentheses on both sides. And on this right side with that negative sign, I want you to distribute a negative 1. So here's what you should get after you distribute. And then the next step is to look to see if you can combine like terms, as long as the like terms are on the same side of the equal sign. And in this case, we can. We have 5m minus 2m. So that will leave us with, on the left, 3m minus 4, and on the right, negative 2m minus 15. Let's get our variables onto one side. So I'm going to add 2m to both sides. So the 2m's cancel on the right, and I'm left with a negative 15 on the right. And on the left, 3m plus 2m is 5m, and then a minus 4 left over. Now I'm to a two-step equation, so I can add 4 to both sides. So here they cancel, and I'm left with 5m equals negative 11. So if I divide, I will get that m equals negative 11 fifths, which equals negative 2 and 1/5, which equals negative 2.2. I would accept any of these answers as your final answer. So now pick one of those representations of your final answer and plug it back in to see if it checks. In this case, you had to plug in your answer into 3 different locations and then simplify both sides, and you should get on the left side that it simplifies to negative 10.6, and on the right side it also simplifies to negative 10.6. So it creates a true statement, so our answer is correct. Now let's look at some special cases. The two types of special cases are called either an identity or a no solution. Identity also means that there are an infinite number of solutions to the equation. So let's first look at the blue one, and let's solve it like we normally would. You'd start with distributing. So 10 minus 8a equals 10 minus 8a. So I know you've seen this before. We have the exact same thing on both sides of the equal sign, which means there are infinite solutions, which means it's an identity. But let's say we didn't even realize it and we continue to solve this equation. By getting our variables onto one side, you would add 8a to both sides. And in this case, your variable cancels on both sides and you are left with 10 equals 10. So our variables canceled out and you get a true statement, which makes this an identity, which also means that in the original equation there are an infinite number of solutions. So now let's look at the right equation and solve this like we normally would. Nothing to distribute, but we do have like terms to combine, 7m minus m. So 6m minus 5 equals, if we combine like terms, we get 6m on the right side, and then plus 7. So you might be able to look at this right now and automatically know that no way will there be a solution, because you can't take 6m, subtract 5, and then 6m and add 7 and ever get the same solution. But once again, let's continue and solve this as if we didn't realize that. So we would try to get our variable onto one side, so I would subtract 6m. Subtract 6m. But they cancel on both sides, and it leaves you with negative 5 equals 7. But after our variable cancels out, that is a false statement because negative 5 does not equal 7. So if you ever get a false statement, that means there is no possible solution to the original equation. Have you and your family ever had to move and maybe even rent a moving truck? Well, let's look at this story problem about Hans. It says that Hans needs to rent a moving truck. Suppose Company A charges a rate of $40 per day, and Company B charges a $60 fee plus $20 per day. For what number of days is the cost the same? So we want to look at the pricing of Company A and the pricing of Company B, and then see when the two companies will be the same. Company A charges $40 per day, no matter what. And then Company B charges, they're going to charge $60 no matter what, but then after the $60, they only charge $20 per day. So just make sure you note that X represents the number of days that Hans will need the moving truck. Well, now we can just solve this equation. Get our variables onto one side, so I'm going to subtract 20x on both sides. So our x's cancel out on the right, and we have 20x equals 60, and then divide both sides by 20, and you should get that x equals 3 days. So what that means is, if Hans is going to rent the truck for 3 days, it does not matter which company he chooses. But if he's going to rent for less than 3 days, which company would he want? He would want Company A if it was less than 3 days. But anything more than 3 days, he's going to want Company B. So you just have to look at the two companies, set them equal, and then figure out how many days it would be for them to be the same. So there's your full lesson on variables that are on both sides of the equation and how to solve them. So good luck.